Ever thought about what really holds our cities together? What keeps skyscrapers upright? Roads smooth? Dams solid? And why is it that whenever someone says concrete, someone else always says, no, that's cement? So what's the difference? What even is cement? In this video, we're going deep into something that's everywhere but rarely noticed: cement. We'll break down what cement actually is, how it's different from concrete, where it came from, how it's made, who uses it, and why it's both a miracle and a menace. We'll also explore green alternatives, future tech, and the companies running this massive industry. If you're someone who loves knowing how the world works, this one's for you. And if you enjoy educational content that's well-researched and easy to understand, please hit subscribe. We're here to offer valuable info for free. Comment below with topics you're curious about. We'll research them and deliver it right to you. What is cement? Cement is a fine gray powder that reacts with water to form a rock-like mass. It's not the same as concrete. Cement is just one ingredient in concrete. Concrete is a mix of cement, water, sand, and gravel. Think of cement as the glue that binds everything together. The most commonly used type is Portland cement, made mainly from limestone and clay. When mixed with water, it starts a chemical reaction called hydration, turning the powder into a hard, durable material. Cement is versatile, cheap, and easy to use, making it the backbone of global construction. It's found in buildings, roads, bridges, and even artworks. Do you realize that this simple substance has enabled the growth of our cities and homes? It shapes how we live, move, and build. Without it, there would be no foundations, no towers, no highways, just the dream of progress. A brief history of cement. Humans have been using cement-like materials for thousands of years. The ancient Egyptians used mud and straw to make bricks. The Greeks and Romans took it a step further. The Romans famously used volcanic ash mixed with lime to create pozzolanic concrete, structures of which still stand today. Fast forward to 1824, when British mason Joseph Aspdin patented Portland cement, named after Portland stone, which it resembled. His invention was the game changer, leading to modern cement as we know it. Since then, cement has become the key to building civilizations. From the Hoover Dam to the Burj Khalifa, this gray powder has shaped our world more than almost any other material. Even during wars and disasters, cement has been a constant in reconstruction efforts. Its history is not just about buildings, it's about humanity's resilience and ambition to rise higher and go further. How cement is made? The journey begins with raw materials, mainly limestone, clay, and sometimes iron ore. These are crushed and blended, then fed into a kiln, a rotating furnace that heats the mix to over 1400 degrees. This process forms small nodules called clinker. The clinker is cooled and ground into fine powder, with gypsum added to control setting time. The final product, cement. Modern factories use automation, AI, and sensors to optimize the process and reduce emissions. Some plants even recover heat and reuse it, making the process more energy efficient. Still, it's one of the most carbon-intensive industries globally. A single plant can produce millions of tons per year. Some facilities now integrate alternative raw materials like industrial waste or construction debris into the mix. This not only cuts emissions, but also makes cement production more circular and sustainable. Types of cement. There are many types of cement, each suited for specific tasks. Ordinary Portland cement, OPC, is the standard for general construction. Rapid hardening cement sets faster, useful in cold climates, and sulfate-resistant cement is designed for marine or chemical environments. White cement is used for decorative finishes. Blended cements, which include fly ash or slag, reduce environmental impact. There's also geopolymer cement, an emerging eco-friendly option. Each type serves a purpose, and understanding them helps engineers and builders choose wisely for durability and safety. In architectural marvels and mega dams, specific types of cement are critical. Even things like colored pavements or polished countertops require specialty cements. The world of cement isn't just functional, it's deeply technical and artistic too. Why cement is so important? Cement is everywhere. It's used in homes, schools, offices, roads, bridges, tunnels, dams, and even airports. Without cement, the modern city wouldn't exist. It allows for fast, scalable, and strong construction. Cement-based structures are durable and low maintenance. That's why the global cement market is worth over $300 billion. Developing countries depend on it for infrastructure growth. It's more than just a material, it's an enabler of economic development and modern life. Cement doesn't just support buildings, it supports progress, healthcare, education, and transportation. In humanitarian aid, rapid housing is often built with cement. In disaster relief zones, cement is used to rebuild and restart life. Its impact is far-reaching and deeply embedded in our civilization. Who uses it and how? From massive construction companies to small home builders, cement is universally used. Architects specify it in design plans. Engineers calculate its load-bearing strength. Masons and contractors mix it daily. Even DIYers use cement for patios or garden paths. Precast concrete elements like beams and pipes are also made with cement. In remote areas, it's often hand-mixed with shovels and buckets. In cities, it's pumped through high-tech systems into formwork. No matter how it's used, the principle remains the same. Cement gives structure to our ideas. And with global urbanization, demand is growing. It's used in everything from skyscrapers to sewage systems. Everyone from artists making sculptures to engineers building metro tunnels relies on cement. Benefits of cement. Cement offers unmatched strength, affordability, and versatility. It can be molded into any shape, making it ideal for both functional and artistic uses. It's water-resistant, fireproof, and low maintenance. Cement structures can last decades or even centuries. When used with steel reinforcement, it becomes even more resilient. Its fast-setting nature makes it perfect for urgent infrastructure projects. In short, it's reliable, accessible, and crucial to modern life. Cement can also improve thermal insulation and help reduce indoor temperature swings. In some cases, specific blends are used to reduce noise pollution in urban environments. Its benefits span from structural stability to aesthetic and comfort enhancements. Environmental risks. Cement has a dark side. It's responsible for about 8% of global CO2 emissions. The energy-intensive kiln process and the chemical reaction itself release large amounts of CO2. Plus, limestone extraction can destroy natural habitats. Dust and pollutants from cement plants affect air quality. While efforts are underway to reduce emissions, like carbon capture, alternative fuels, and green cements, the industry still has a long way to go. The challenge is balancing infrastructure needs with environmental responsibility. Water use in production also stresses local ecosystems, and improper disposal of cement-based materials can lead to ground contamination, affecting both humans and wildlife in surrounding areas. Alternatives and green innovations. Thankfully, alternatives exist. Fly ash cement uses waste from coal plants. Slag cement reuses byproducts from steel production. Geopolymer cement skips limestone entirely, reducing carbon output by up to 80%. Some startups are working on biocement, using bacteria to create binding agents. 3D printing with cement is reducing waste and labor costs. The future is promising, with innovation driving change. Still, adoption is slow due to regulations and cost. But as climate pressures mount, the shift will accelerate. Researchers are also exploring using recycled plastic in concrete mixes and developing AI systems to reduce waste in cement usage on site. Industry leaders and global reach. Top global producers include LafargeHolcim, Cemex, Heidelberg Cement, and China National Building Material Co. China leads in production, responsible for over 50% of global output. India, the US, and the EU follow these giants-shaped policy, invest in R&D and influence pricing. The industry employs millions worldwide. Cement connects not just bricks and beams, but also people and economies. Understanding its global scale highlights its impact and the need for sustainable progress. Many of these companies are now pivoting to sustainability, launching eco-label products, and adopting stricter emissions tracking. Their choices will determine whether the future of cement is clean or catastrophic. So next time you walk on a sidewalk, cross a bridge, or sit inside a tall building, remember, you're surrounded by cement. It's invisible, but without it, modern life would collapse. It's both a marvel and a menace, strong but polluting, vital yet destructive. Understanding cement helps us appreciate its power and our responsibility to use it wisely. Thanks for sticking around. If this video taught you something new, please like, share, and subscribe. It really helps us grow and keep offering free educational content. Have a question or topic in mind? Drop it in the comments. We'll research it and bring you another deep dive